My name is Dr. A.Mustapha from Kwara State University, Malete, Nigeria. My presentation is synthesis and evaluation of ArkydResins from underutilized seed oils. These are Delonix, Regia, and Theventia, Peruviana. My outlines are abstracts, introduction, statement of problem.
Mustapha.
Hello?
Yeah, sorry about it. Can you put your slides on a presentation mode so that they can be able to see them clearly this side?
Okay.
Yeah.
Okay. Presentation mode.
I think it's down there. Yeah.
On the top bar, click slideshow.
Hello?
At the top. Click slideshow there at the top.
Yeah. Have you seen it?
You see where you have home, insert, design, animation.
Have you seen me? Is it okay now?
Not yet.
I'll put it on a film mode.
Maybe our IT can share from our side your presentation.
Hello?
I was saying maybe our IT can share your presentation from our end.
Okay, no problem.
Lebo, can you kindly assist Dr. Mustapha?
Thank you.
Stop sharing, doctor.
Lebo, are you winning?
Yes, it's loading.
Okay.
Yeah, there you go. You can continue.
Thank you very much. My topic, like I said, is synthesis and evaluation of ArkydResins from underutilized Delonix, Regia, and Theventia Peruviana seed oils. My name is Dr. Mustapha from Kwara State University, Malete, Nigeria. Next slide. My outlines are abstract, introduction, statement of problems, aim and objectives, and it runs to conclusion and references. Next slide. These are my abstracts. It illustrates the introduction, the statement of the problem, the materials and methods, and the result. This is my introduction. ArkydResins are vegetables oil, are made from vegetables oils and polyols and diabetic acids. We can make indigenous ArkydResins from non-edible vegetable oils. And these non-edible vegetable oils are grown in poor soils. They are readily available. They don't compete with foods. They are less expensive. And these are alternative production for ArkydResins using local materials. There are different types of vegetables. We have dry, we have non-dry, and semi-dry. This classification depends on their length of fatty acid chain. The statement of the problem. Statement of the problem. There's a local, we need to intensify the local production for alternative production of ArkydResins. But we use ArkydResins for furnishes and paints. And Nigeria depends only on imported ArkydResins. So we want to look for indigenous raw materials to produce ArkydResins. One, to reduce cost, to enhance availability, and to compare our locally produced ARUA standard requirements and compare them with imported ones. Next. These are the aims and objectives to produce and characterize different types of ARUA using indigenous feedstocks, Delonix, Regia, and Theventia Peruviana. Objectives are to extract and refine, determine and compare chemical properties, assess the effect of viscosity and acid values against reaction time, to measure chemical solidification and dry test, and to monitor the changes in functional group using FTIR. Next. These are my literature. We have an example of diabetic acid, phytalic acid, isophytalic anhydride, and malic anhydride. Next. The proportion of starting materials determine the kind of ARUA. We have long. The proportion for the long is between 16 and above % of the starting raw materials, particularly the oil. And the medium is between 40 to 60%, and the short is around 25 to 40%. This proportion determines the kind of ARUA we produce. Then the type of oil also determines the chemical nature of the ARUA. That is when we are talking of dry oil, semi-dry oil, and non-dry oil. There are two major stages of production: alcoholysis stage and esterification stage. Next. Next. We have our triglycerol, that is our vegetable oil. We put at an enhanced temperature of around 240 degrees, and the triglycerols are broken down into monoglycerides, and diglycerides. At that enhanced temperature, the phytalic anhydride is added to produce our ARUA. And these are the structures, that is formation of ARUA that you have seen. Next. All the chemicals are there, and instrument and equipment that were used are listed as well. Next. These are experimental methods. We get our vegetable oils. We have to do extraction. We have to do refinement so as to reduce the percentage of fatty acid present. If you don't refine our oil, there will be high free fatty acid present. And instead of giving us better heat, it will reduce our heat. So the first thing we do, the cold extraction using normal exhaust. After the normal extraction of our seed oil, we went into refining of our oil. And these are 3 stages. The stages are degumming to remove all the phosphatides in the crude, and we do use alkaline treatment so that you can neutralize the free fatty acid present, and we do the bleaching. After that, we go into the physiochemical and properties of the oil so as to see the level of fatty acid, the profile of fatty acid, and all other parameters like acid value, saponification value, iodine value, etc. Then we move into the production itself, that is alcoholysis stage, breaking down triglycerides into mono and diglycerides using carbonate as a catalyst. After that, we lower the temperature and we add our glycerol, and that is the esterification stage. The esterified hydroxyl group from glycerides with carbonic group is now added with phytalic anhydride, and we sustain this reaction under at the temperature between 240 degrees Celsius, and we maintain the reaction mixture to continue for 4 hours. Next. Then we have our results. This table 1 is physicochemical properties of refined Regia, refined oil, and refined Theventia Peruviana refined oil. We have the parameters color, we have acid value, saponification value, iodine value, and percentage free fatty acid. And the data are stated in table 1, and they fairly comply with American standard for testing material standards. Next. In table 2, we show the physical chemical properties of large Alkyd resins for the 2 samples. That is, for the Regia oil Alkyd resin and Theventia Peruviana oil Alkyd resin. And we have commercial Alkyd resins so as to compare our parameters to meet up with imported Alkyd resins. Here we compare the parameters of color, acid value, saponification, iodine value, specific gravity, and viscosity at temperature 30 degrees Celsius. So these tables are presented. Next. Next, please. Next slide. Then you can see, no, please go back. Yes, table 3. Go back, please. Yeah, that is table 2. So chemical properties of like I've discussed that. Next. Next, please. Yes, this is no figure 2, please. Figure 2, please. Yes, thank you very much. So this our acid value graph plotted against time from the starting of Alkyd resin production to 100 minutes. We have acid value against reaction time. For all the long, medium, and short Alkyd resin for the Delonix Regia and long, medium, and short for Theventia Peruviana, we have the 6 samples. You can see the acid value decreases with time. And from the literature, if you measure the acid value and they are less than 10, that is when we know that once the acid value is less than 10, that is 10 milligram per potassium hydroxide, by 100 gram of potassium hydroxide, we note the reaction has completed. You can see that as the reaction progresses, the acid value decreases. Next. Figure 3, please. Now in figure 3, we tried to evaluate and see the trend of viscosity changes as reaction progresses. And also for the long, medium, and short Alkyd resin of Delonix Regia and Theventia Peruviana, we can see that viscosity against reaction time increases. Of course, that is expected because these are polyesters. As Alkyd resins production increases, of course, we expect viscosities to increase correspondingly. And that is what is showing in the graph for all the 6 samples. Next. Now in table 3, we have to compare the chemical resistance of Alkyd resin. Because most of these Alkyd resins, they have exposure time. So we want to see all the 6 samples that are produced, we put them in our 4 media. The first medium is distilled water. And we have our table. If you note the table 3, you can see the film present, FP. If the film is not up, if the film is absent, we say FA. For distilled water, the film present are indicated. For sodium hydroxide at concentration of 0.1 molar, we have the film absent in some cases, and I think it is film absent in all. Sulfuric acid H2SO4 at 0.1 molar, we have the film present. At 5% weight by weight sodium chloride, we equally have the film present. Thank you. Next slide. In table 4, we did dry tests of Alkyd resin. That is, we have to see the coating properties: dry through, set to touch, and surface dry. See that at different times immediately this Alkyd resin is produced. We have to put them in we have to expose them to atmospheric air and see. The dry through is when the film is at instant that film wants to set in. And that is for long, the Regia oil Alkyd resin, the dry through is 2 hours. For medium,
you have a minute left there, Mustapha.
Thank you.
All right.
Next. Then we have Alkyd resin solubility in solvent. Next. We have solidification time of AlkydResins. Next. We have the FTR analysis that we use to monitor the functional changes, and that confirms the process of AlkydResins. Next. These are the interpretation of our FTR for all the AlkydResins. Next. Next, please. All these are FTR interpretation. We have extracted our 2 seed oils using calcium carbonate, and we compare the physicochemical properties. We find the colors were characteristic of different types of oil. The viscosity were measured. The ranges of degree of polymerization show the molecular weight increases. Then we have active films, and we did our long surface drying period for about 2 hours, and that is for standard 60% accuracy. The solubility were highly influenced by the proportion of starting material. Solidification and chemical resistance tests compare well to commercial AlkydResins. The yield for Theventia Peruviana is 78.9, and for Delonix Regia is 54.88. The FTR, of course, were used to monitor the progress of the reaction. Thank you for this opportunity.
Thank you very much, Mustapha,
Thank you.
for your presentation.
Thank you.
And yeah. All right. Thank you very much. Let's move on to the next presentation. I hope the presenters are ready. And then for your attention to the attendees, the presentations will be sent or shared after the conference is done. So if you have any questions, like Professor Konish has said, can you post them on the chat? And then I'll ask all the speakers to view them at the Q&A so that they prepare to provide you with answers.